Okay, guys, enigma research. Giza pyramid as observatory. Let's start.
The Giza pyramids, specifically the Great Pyramid of Khufu, is these monumental tombs, the ultimate symbol of a pharaoh's eternal rest. But what if that perspective, well, yeah, true in part, misses the main point, the primary architectural intent?
Exactly.
What if that massive stack of limestone and granite wasn't just for eternal rest, but was designed as a precision instrument? Maybe the largest one ever built, actually, just for measuring the heavens.
That is precisely the core of our deep dive today. We're really challenging that passive view, the pyramid, as just a tomb idea.
Right.
And substituting it with something much more dynamic, an active, functioning, scientific observatory.
Okay, so what are we basing this on? What kind of sources are we looking at here?
Well, the material we've pulled together combines really detailed historical reconstruction with modern archaeoastronomy.
Archaeoastronomy.
Yeah. Okay, that's the rigorous study of how ancient peoples understood the sky, how they used it. It's quite fascinating.
And crucially, we're moving beyond just like vague alignments, right? This isn't just, it points roughly north.
Oh, absolutely. We have the internal geometry, the specific cultural context, the myths linking to Osiris and Isis, which are vital, and the hard, measurable numbers. These suggest the pyramids weren't just monuments, they were sophisticated, fixed sighting instruments.
So the central idea we're digging into.
The hypothesis, is that those narrow internal shafts in the Great Pyramid, they were designed as precision optical devices.
Not air vents.
Not just air vents, no. That theory doesn't really hold up well. These were, we think, fixed sight lines meant to capture the light of specific, culturally vital stars.
Like Sirius.
Sirius, definitely. And the ancient North Pole star, Thuban. And possibly even project them onto the chamber walls for, state-level calendrical measurement.
Wow. The technical suffice for the Old Kingdom. That's pretty profound.
It really is.
So to really get a feel for this blend of science and spirituality, we need to start where they started. Not with blueprints, but well, you paint a picture for us. A scene from the Fourth Dynasty.
Okay.
Deep inside the king's chamber, on the most important night of the Egyptian year. The night of Sophis rising.
Right. So our sources let us kind of imagine walking alongside Nebka.
Wow.
He's the son of the temple scribes of Heliopolis.
Okay.
And he's entering this sacred architecture. Just imagine the sensory experience. You go from that harsh desert sun.
Blindingly bright.
Yeah, into this profound, cool stillness inside the core. The air is heavy. You can almost smell the oil smoke, the polished stone, and you feel this absolute ancient weight of silence. It presses on you.
And the door.
The heavy granite door swings shut, boom, sealing you inside the earth.
Wow.
And they're not thinking tomb, they are in a ceremonial structure. It's designed to interact with the sky. The priests actually called this space the Persahu, the house of the transfigured one. It's essentially a working lab for celestial mechanics. Nebka is warned, the breath of the stars flows through these stone mouths. We disturb it only with reverence and precision.
So very serious.
Extremely. The only light is from flickering sesame oil lamps. Their weak flames barely cast shadows on these huge, smooth walls as they go down into the king's chamber itself.
That room. The granite box, right at the heart of this massive structure, it must have been overwhelming.
It really must have. Nebka, in this hypothetical reconstruction, notes how his whisper seemed to just hang there, balanced perfectly between the walls, like a single note caught in a perfect musical instrument.
That architectural perfection, the sheer accuracy of the angles. It's immediately tied to why they're there, isn't it?
Absolutely. This chamber, they called it the Eye of the Horizon. It's where the rhythms of the cosmos were captured, measured, recorded.
And it wasn't just anyone wandering in. There was a specific team, right?
Oh, definitely. The personnel there underscore the seriousness. This was a highly organized, almost bureaucratic setup. A scientific hierarchy, not just some spontaneous ritual.
What was involved?
Leading the descent, you have the Hemkara, the servant of the spirit of Ra. He's overseeing the ritual purity, making sure everything's correct in that sense.
Okay.
But the key figure for our discussion really is Ta'amonk. He's the Cariheb.
Cariheb.
Chief ritualist, yes, but more importantly, the master of calibrations. His authority is technical. He's responsible for the accuracy.
Hey, master of calibrations. I like that.
It says a lot, doesn't it? Then you have the specialists, the data collectors.
I agree.
Hori. He's the Sesh Sepedet, the keeper of the star tables. He's got his reed scrolls, his mineral inks, all ready to instantly record the observation the moment it happens.
Wow, instant recording.
And critically, Tetiamon. He's the Hemsebo, the servant of the stars. His entire highly specialized job was the maintenance and the absolute perfect alignment of the optical instrument setup.
The instrument? You mean the shafts themselves? Or something else?
Well, specifically what they installed at the mouth of the shafts. We're not talking modern glass lenses, obviously.
Right.
But highly burnished bronze mirrors, resting in small, precisely carved sockets right near the shaft openings.
Bronze mirrors. Polished.
Polished to a sacred sheen, yes. Designed to capture and focus that faint starlight with maximum efficiency. They function as the optical element of this massive stone camera.
Okay, so tonight is the big night. The apex of the whole Egyptian calendar year. Why? What are they waiting for?
They're waiting for the Sothic star. Sepedet, that's what we call Sirius.
Yeah, Sirius, okay.
They're waiting for its first heliacal reappearance. That means the first time it's visible just before sunrise after being hidden below the horizon for 70 days.
70 days. Why that number?
Because 70 days was the period associated with death and rebirth in their culture. It mirrored the time needed for mummification. So, the return of Sirius marks the renewal of the world. It signals the exact moment the Nile River, the literal lifeblood of Egypt, would begin its vital annual flood. The stakes, the entire state agricultural calendar, the ritual calendar, everything depended on this observation.
Wow. No pressure then.
None at all. And the process is meticulous. It takes time. Tetiamon, the mirror guy, takes his position by the southern shaft. First, he uses a lamp and maybe a polished stone just to confirm the path is clear. Make sure light travels the whole length unobstructed.
Checking the alignment.
Exactly. Then he carefully adjusts the position of the concave bronze disc, the mirror. It's designed to catch that faint glimmer from the dawn sky and focus it down that long shaft into the chamber.
And Nebka is watching all this.
Watching with intense focus. Slowly, a pale shimmer appears. A little trembling spot of light on the granite wall opposite the shaft opening. He whispers, maybe worried he missed it. Is that her? Sepedet?
Yeah.
And Hori, the keeper of the star tables, Mr. Data himself, quietly, scientifically corrects him. Not yet, Nebka. That is Sa, the hunter Orion.
Orion first.
When his shoulder star, Alnitak, clears the horizon, Hori explains, Sepedet follows exactly 17 minutes later. This shows they aren't just guessing based on myths.
Right, they have timings.
They have precise timing data, known star sequences, geometric constants. They are tracking the calendar of a fret, the season of flood, moment by moment, using known celestial markers.
Okay, so Orion fades, then what?
Then the moment arrives. That initial shimmer from Orion fades slightly and is followed by an immediate dramatic brightening. The spot of light takes on this distinct, piercing, bluish hue, and it steadies. It just burns with this clarity that cuts right through the dim chamber.
That's serious.
That's serious. Monk, the master of calibrations, raises his hands. It's a ceremonial declaration, but it's also scientific confirmation. Behold, Sepedet Neteru, the soul of Isis returns. Yeah. The ritual language is layered right over the scientific observation. Our sources describe the mirror beam producing an image of Sirius that's sharp as a crystal tear.
Sharp as a crystal tear.
And for Nebka, this is the profound aha moment. This is way more than just worship or simple alignment. This is precise, fixed measurement, done under controlled conditions. And everything depends on it. Farming, taxes, temple rights, the king's own legitimacy.
So the key takeaway from this scene is what the old priest said.
Exactly what Monk imparts. The pyramid isn't just a tomb. It is an instrument, a stairway of stone that touches time itself.
Wow.
The shafts are mouths through which eternity speaks, allowing these specialized priests to be essentially pupils learning and recording the immutable, measured instructions of the gods. The mythic purpose and the scientific function are just seamlessly woven together.
Okay, that story really sets the stage. Now let's pivot from that immersive narrative to the cold, hard scientific analysis that might actually validate this stunning claim.
Right. Time for the evidence.
The short thesis, the core idea we need to back up now, is that these pyramids combine extraordinary directional precision. Shafts aimed very specifically at key stars, and strong textual and mythic links. All these things together support the idea they were meant for accurate astronomical sighting, timing, maybe even projection.
And the first pillar of evidence is just the sheer, overwhelming structural precision of the Great Pyramid itself. When you look at this as an engineering artifact, the metrology involved, it rivals and in some ways honestly exceeds much later civilizations.
People talk about the precision, but the numbers are just mind-blowing. We're talking about aligning the base. This structure is over 230 meters on each side. Aligning it to the cardinal directions, north, south, east, west.
With an error margin of only a few arc minutes.
A few arc minutes. That's less than 1/15th of a single degree. Over that huge distance. It's staggering.
It really is. And it's not just the direction, the side lengths themselves, the perfection of the squareness. It's measured to centimeter, sometimes even millimeter accuracy across hundreds of meters.
Try doing that today, even with lasers.
Exactly. For the fourth dynasty, it requires explanation.
And here's the crucial link, right? How do you get that precise? Experts argue that achieving this level of alignment, well, it plausibly required repeated, careful, long-term astronomical observations.
Precisely. To set your north-south line that accurately, you pretty much have to track the rising and setting of a star and bisect the angle, or even better, observe the constant rotation of the pole star over time.
So the skills needed for the surveying
are exactly the same observational skills you need to build a sighting device, like these shafts. You don't stumble into that kind of precision. You get it by tracking something fixed and predictable in the sky.
Which brings us neatly to the second line of evidence. The shafts themselves, their stellar geometry.
Right. The very existence of these four narrow shafts, two in the king's chamber, two in the queen's chamber, aimed north and south, that's the physical hint of astronomical intent right there.
They don't seem to serve a major structural purpose.
Nope. And the idea that they were purely for ventilation, it's never really fully explained things, especially the precision of the angles.
And the targets aren't random, are they?
Far from it. The north shafts aim high, up towards the circumpolar stars, the indestructible stars, as the Egyptians called them.
Because they never set.
Exactly. They never dip below the horizon, symbolizing the king's eternal, unwavering spirit after death.
Makes sense. And the south shafts.
They aim lower, towards stars tied to cycles, calendrical cycles, funerary cycles. We're talking Sirius against Sothis and the Nile flood, and parts of Orion linked directly to Osiris, the god of rebirth.
So if the shafts were just random holes?
The odds of them just happening to hit such specific cosmologically vital targets would be incredibly small. Vanishingly small, really.
Okay, precision, specific targets. Now the third point, maybe the trickiest, the technology. Could they actually see anything useful down those long, narrow tubes? This is where the skepticism often comes in, right? It's just a dark, long hole.
It is, but that's kind of misunderstanding how ancient optics could work and maybe what the goal was. We're not talking about high magnification, like a modern telescope.
Okay, so not seeing details on Mars.
No, definitely not. We're talking about light concentration, or flux concentration. Think about the opening, the aperture of the shaft. It's maybe 18 to 21 centimeters wide. That's quite large compared to your eye's pupil.
Right.
If you combine that large opening with a polished, concave metal mirror at the bottom, the whole system acts like a powerful pinhole camera, or maybe a folded optic.
Flux concentration. Can you break that down simply?
Sure. Think about looking up at a star. Your pupil is maybe 5 millimeters across. That's how much light your eye collects.
Okay.
The shaft opening is 20 centimeters. It collects way more light. Hundreds of times more. Now, if all that light collected over that big area is channeled down a dark tunnel and focused onto a small spot by that concave mirror,
the light energy gets concentrated.
Hugely concentrated. The light flux, that's the brightness per unit area, becomes intense enough to be easily visible, even if the actual image size is tiny.
Oh, okay. So the goal wasn't to get a big image, but a bright image. Bright enough to see clearly, measure its position, time its arrival.
Exactly. Make it unmistakable inside a dark room. This setup could definitely project visible images of bright objects, the moon certainly, maybe bright planets, and definitely the brightest stars onto a chamber wall.
And that's perfect for ritual timing, you said.
Perfect. It allows for controlled, repeatable, synchronous observation by multiple priests inside a dark, highly sacred space. Much better than having one guy squinting at the horizon outside, trying to catch the first glimpse through haze or dust.
This sounds incredibly sophisticated, but let's tackle the skepticism head on. The main objections we find in the sources: structural issues and missing gear.
Right. The first one is that some shafts, especially the Queen's Chamber ones, are bent or seam blocked, so they couldn't be practical telescopes. And our response, based on the sources, is twofold. First, the King's Chamber shafts are highly accurate. Second, even the QC shafts, with their kinks or blockages, might only need to serve as fixed symbolic sightlines. Maybe for timing a star's transit very briefly, or for short pulse projection events. They don't need to be high-res instruments for continuous viewing. Ritual needs often prioritize symbolic visibility and exact timing over perfect imaging.
Makes sense. And the second argument, where are the mirrors? If they were so crucial, why haven't we found any?
Yeah, the missing mirrors argument. We have to be really careful not to mistake absence of evidence for evidence of absence. We're talking 4,500 years here.
True.
Metal tarnishes. Bronze mirrors, even if highly polished, wouldn't survive well in the environment inside a pyramid unless they were somehow perfectly preserved. It's just unlikely.
And we know they could work metal.
That's the other point. The Egyptians clearly had the workshop skills to achieve centimeter scale geometry on the pyramid base. If they could align a 230-meter structure to arc-minute precision.
They could polish a small mirror.
Exactly. They undoubtedly possessed the metalworking skills to polish small, concave bronze mirrors to the quality needed for simple light focusing and projection. The capability is strongly implied by the architecture itself.
Okay, so the basic idea is plausible. Let's get into the specifics now. The geometry, the math, this is where it gets really crunchy, right?
Right. This is where we move from a compelling story to a rigorous scientific argument. And the core methodology used by archaeoastronomers here relies on something called the meridian assumption.
Meridian assumption. Sounds technical. Break that down for us.
Okay. The meridian is basically an imaginary line in the sky. It runs from the true North Pole straight up through the point directly overhead that's called the zenith, and then down to the true South Pole.
Like a line dividing the sky in half, east and west.
Exactly. A star is on the meridian when it reaches its highest point in the sky during its nightly journey. The meridian assumption is simply that the priests used the shaft to sight the star at that specific moment, when it was highest.
Why assume that? Does it make things easier?
It simplifies the calculations enormously, because when a star is on the meridian, its position relative to you, the observer, is purely a function of your latitude on Earth. And the star's celestial latitude, its declination.
Declination.
Yeah.
How far north or south it is in the sky.
Precisely. So if we know the observer's latitude, which for Giza is about 29.98 degrees north, and we measure the shaft's angle, its altitude above the horizontal.
Which we know from surveys.
Yes. We can use a simple trigonometric formula to calculate the required declination of the target star. The architecture literally gives us the astronomical coordinate.
Okay, let's run the numbers then. The measured shaft altitudes are King's Chamber North is about 32 degrees 28 minutes. King's Chamber South is almost exactly 45 degrees. Queen's Chamber North is around 39 degrees, and Queen's Chamber South is 39 degrees 30 minutes. Let's start with the north shafts, the indestructible stars. KC North first.
Okay, King's Chamber North, altitude 32 degrees 28 minutes. That precise angle yields a target declination very, very close to the North Celestial Pole, about plus 87.5 degrees. This angle is critical.
And what star was sitting way up there, near the pole, around 2500 BCE, when Khufu's pyramid was likely built?
That alignment points directly, almost perfectly, at Thuban, Alpha Draconis, which was the historical North Pole star during the 3rd and 2nd millennia BCE.
Wow. Okay, that sounds like a bullseye.
It's arguably the strongest, most robust connection we have for any of the shafts. And its function makes perfect sense. It serves as the constant, eternal, nightly anchor for the entire cosmos. It fits perfectly with the funerary symbolism, the pharaoh joining the imperishable stars that never die, never set.
If you're building a monument to eternity,
You absolutely align your main northern observation shaft to the star that, from your perspective, never moves and never sets.
and this connects directly to that concept of precession, right? We need to explain that, because it's key to why these shafts are like time machines.
Yes, precession is absolutely vital here. Think of the Earth spinning like a top. As a top slows down, it starts to wobble, right?
Yeah.
The Earth's axis does the same thing, very, very slowly. It traces out a huge circle in the sky. This wobble takes about 26,000 years to complete one full cycle.
26,000 years.
Yeah. So because of this wobble, the point in the sky that our North Pole points to gradually changes over the millennia. Polaris is our pole star now, but it wasn't for the ancient Egyptians. Thuban was.
So a fixed architectural sightline, like this shaft.
Becomes a clock that tracks geological time. By knowing the precise angle of the shaft and the known rate of precession, astronomers can calculate the exact historical moment when Thuban would have been perfectly centered in that sightline.
And when was that?
The best fit comes out right around 2500 BCE, which is a powerful independent verification of the traditional archaeological dating of the pyramid itself. The astronomy confirms the archaeology.
Okay, so KC North is the cosmic anchor fixed on Thuban, locking in the date. What about the other north shaft, Queen's Chamber North? It's a bit lower, 39 degrees altitude.
That shaft targets a declination of about plus 81.0 degrees. While not the pole star itself, it points towards other bright circumpolar candidates in that era, notably Kochab, Beta Ursae Minoris, in the Little Dipper.
So maybe a secondary check.
Possibly. It suggests that builders might have sought redundancy, maybe multiple alignments within that circumpolar region, providing multiple checks on rotational alignment or timing throughout the night.
Okay, let's turn south now, to the crucial calendrical stars. The King's Chamber south shaft. This one's aimed at a near-perfect 45-degree angle.
That 45-degree altitude is fascinating. It yields a target declination of approximately negative 15.0 degrees. And that number is incredibly significant.
Why?
Because it falls extremely close to the declination of Sirius Southus during the height of the Old Kingdom, around 2500 BCE.
You say extremely close, not perfect. Does that tiny discrepancy matter? Does it weaken the case?
Not really, no. You have to account for slight variations in measuring the shaft angle accurately over its entire 60-meter length. Plus, the star's exact position changes slightly over centuries due to precession and its own motion, but the fit is so strong and Sirius is so culturally important that it remains by far the most plausible candidate. This shaft was arguably the most critical instrument for the entire Egyptian state.
Why Sirius, above all others? Remind us again.
Because of the Sothic cycle. As we discussed earlier, that heliacal rising of Sirius when it first pops up just before dawn in mid-July after its 70-day absence, that was the single non-negotiable astronomical event. It signaled the imminent start of the Nile inundation, the flood, and marked the beginning of the civil new year.
Everything depended on it.
Everything. So having a precise, fixed instrument like this shaft, allowing priests to verify that exact moment in the controlled darkness of the chamber, that would be the most valuable state tool imaginable.
Okay, makes sense. Finally, the Queen's Chamber south shaft.
Yeah.
Angle, 39 degrees, 30 minutes. Declination, about negative 20.5 degrees.
Right. This declination is too far south for Sirius, but it falls very neatly into the celestial neighborhood of the Orion constellation saw, as they knew it. Specifically, it aligns well with the region of Orion's belt stars, like Elnatek.
And Orion was linked to Osiris.
Inextricably linked.
Well, Osiris, the resurrected god, so central to the king's funerary beliefs and rebirth cycles. This shaft may be used for projection when Orion was highest in the sky during winter.
Or for culmination.
Exactly. That would provide a precise cue for specific seasonal rites tied to the spiritual rebirth of the dead king in the underworld.
Okay, so we have Thuban for eternity, Sirius for the calendar and life, Orion for rebirth. It fits together nicely. Now let's visualize this. What would a priest using these shafts with maybe those bronze mirrors actually see? Forget Hollywood telescopes. Based on the optical estimates in your sources, what are we talking about? Well, for the biggest, brightest target, the moon, if it passed through the field of view, the image would be unmistakable. Given the shaft dimensions, its effective focal length. The moon's projected image on the chamber wall could actually be quite large, maybe, say, 27 to 63 centimeters across. A clearly visible, bright disk.
Wow, that big. Okay, what about planets? Like Jupiter, if it happened to cross the line of sight.
Planets like Jupiter or Saturn would certainly be visible, but much smaller. Jupiter might appear as a small disk, maybe 6 to 14 millimeters across on the wall. Now, a careful, trained observer in a pitch-dark room could definitely distinguish that as a disk, not just a point of light like a star.
But the stars themselves, the actual targets like Sirius or Thuban.
They would appear as incredibly bright pinpoints of concentrated light. The actual image scale might be sub-millimeter, tiny, but the key is that highlight flux we talked about.
The brightness.
Right. All the light gathered over that 20-centimeter opening gets concentrated into a single sharp point. In absolute darkness, that focused point of light would be easily visible, very stable. Perfect for marking the precise moment it crosses a calibrated line on the wall.
And we need to stress the different uses, right?
Yeah.
The north shafts versus the south.
Absolutely crucial difference. The northern targets, Thuban and maybe Kochab, are circumpolar. They are visible every clear night, all year round, circling the pole. They serve as the constant, immutable clock.
The eternal reference.
Exactly. Conversely, the southern targets are seasonal. Sirius, for its critical heliacal rising, is observed just before dawn in mid-July, but that same shaft could also be used to time Sirius's meridian transit during the winter months when it's highest in the sky at night. And the QC South shaft aimed at Orion. That would only provide its celestial cue during the autumn and winter seasons when Orion is prominent, which aligns perfectly with the timing of major Osirian funerary festivals. So the simultaneously as a calendar, a clock, and a ritual cueing mechanism. It's incredibly integrated.
It really paints a picture of a highly sophisticated, purposeful system. Now, when we talk about these findings, you stressed earlier, it's important to frame this scientifically.
Absolutely vital. This isn't just, archaeological guesswork or speculation. It's presented as a falsifiable, multidisciplinary hypothesis. It connects measurable architecture and geometry to predictable celestial mechanics. It has to stand up to rigorous scrutiny.
And a strong hypothesis should make testable predictions, right? What are some ways this idea could be tested or verified?
Well, one of the primary tests is what's called axiometric epoch fitting. This is where you use computer models. You input the precise measured direction of the shaft and you calculate the positions of candidate stars back through time, accounting very accurately for precession.
And you look for the best match.
You look for the time period, the epoch, where the angular residual, basically the error margin between the shaft's direction and the star's position, is minimized. If the pyramids were built for astronomical sighting around 2500 BCE, the best fit epochs for these stars should cluster tightly around that date.
Makes sense. What about physical evidence? Anything we could look for inside the shafts?
Yes, physical trace analysis. Using high magnification microscopy, maybe even scanning electron microscopy inside the shafts. You'd look for subtle clues, microabrasion patterns that might indicate something was repeatedly inserted or adjusted, small anchor points where mirror mounts might have been fixed, maybe even trace amounts of soot residue from calibration lamps used near the openings. Instrument use should, theoretically, leave some kind of wear or trace.
Hard to find after 4,500 years, but possible.
Difficult, but not impossible with modern techniques. And then, of course, there's experimental replication.
Actually build a mock-up.
Exactly. Build a full-scale mock-up of a section of the shaft. Use materials analysis to estimate the reflectivity of a polished bronze mirror from that era, and then actually test it. Prove that a visible, usable image can be projected under realistic atmospheric conditions like those near Giza. That kind of practical proof is essential to shift the hypothesis from just possible to highly probable.
Okay, so there's a scientific process here. And this process, this rigorous approach, is what led to something unexpected, a surprising numerical finding.
Yes. This is where the data itself threw us a curveball. We know the archaeology is overwhelming. Inscriptions, stratigraphy, carbon dating. It all points very strongly to Khufu's construction being in the mid-3rd millennium BCE. Let's say roughly 2550 to 2500 BCE.
The standard date.
The standard well-established date. But when a coarse astrometric scan was performed looking at star alignments over broad periods, the numbers produced a conflicting signal for one specific shaft.
Which one? And what was the conflict?
It was the King's Chamber South shaft. The one we established generally targets Sirius around 2500 BCE. But the scan showed a near-perfect numerical match and even better geometrical fit for one of the stars in Orion's belt, Alnitak, Zeta Orionis, at a significantly earlier
Yeah,
epoch.
come here. How much earlier?
Approximately 3250 BCE.
Wow, that's 700 years before Khufu.
Exactly. It's a fascinating conflict. It means and it's a big if we assume the KC South shaft was built specifically to target Alnitak crossing the meridian, then an epoch 700 years earlier provides a mathematically better fit for the measured shaft angle than the conventional date of construction. The angular error is minimized in that earlier period.
Okay, that sounds like a potential bombshell. Does this mean we need to rethink the entire 4th dynasty chronology based on this one astronomical alignment?
No, absolutely not. And this is where critical caution is absolutely essential. We cannot overstate that. This numerical result is provisional. It came from a coarse scan done in large 50-year time steps, and it relies heavily on two major assumptions. First, that the builders specifically chose Alnitak out of the 3 belt stars, and second, that they intended the shaft to target the star precisely at its meridian transit rather than, say, its rising point or some other marker.
And the archaeology.
The archaeology remains overwhelmingly strong. The physical evidence inscriptions with Khufu's name found in relieving chambers, pottery styles surrounding mastaba tombs, carbon dates from mortar, all firmly place the construction of the Great Pyramid in the mid-3rd millennium, around 2500 BCE. You don't throw that out based on one provocative but preliminary calculation.
So how do we make sense of this then? How do we reconcile a precise astronomical requirement that seems to fit geometrically better at an earlier date with the overwhelming physical evidence for the later construction date?
Well, it forces us to think more deeply about the design process itself. It raises a really fascinating possibility. perhaps the astronomical alignment requirement, the specification for that shaft, was derived from an older design template. Or maybe an ancestral religious requirement, something set down in texts or traditions hundreds of years before Khufu's pyramid was physically built.
So the builders in 2500 BCE
might have been tasked with executing a pre-existing sacred design. They might have been attempting to honor a precise ancient alignment, a kind of sacred geometry that was actually astronomically perfect back around 3250 BCE.
So the sky offers a date for the design specification, maybe, even if the ground offers a date for the construction.
That's one way to interpret it, yes. The sky gives a potential chronology for the required alignment, which might conflict with the physical chronology of the building itself. It's certainly not proof of earlier construction, but it's a flag, a signal that requires much more precise follow-up research, finer scans, and consideration of alternative targeting strategies.
That idea, building to honor an ancient, precise celestial requirement, it's a beautiful blend of myth and metrology, isn't it? It suggests that while the pyramid was physically constructed in the 4th dynasty, its core design principles might genuinely hark back to an even older, perhaps surprisingly sophisticated astronomical tradition.
It opens up a lot of interesting questions about the transmission of knowledge in pre-dynastic and early dynastic Egypt.
Okay, to wrap up our journey and really illustrate the full dynamic potential of this pyramid as instrument idea, let's return one last time to our narrative. We find Nebka again. He's no longer just an apprentice, he's now a full observer, maybe even known as he who measured the hidden ones.
Right.
And he's in the north shaft corridor, maybe using a more refined instrument this time, something the sources hypothetically call the Eye of Horus. Perhaps a polished crystal disc mounted on a bronze tripod, used for finer observations. This final observation isn't about the fixed calendar, it's about spotting something unusual, something transient.
Exactly. He's waiting for Sa, the hunter Orion, to enter the mouth of the northern shaft this time, maybe the QC north, and strike the alabaster wall inside. This could be a nightly calibration check. He's there with other specialists, Menset, the recorder, whose job is tracing the light paths, and Seret-Hetep, the high observer, leading the technical aspects of the ritual.
So Orion's light comes down the shaft.
And as that silver thread of starlight strikes the wall, Nebka immediately senses something's wrong. An anomaly. The line of light isn't the expected steady point or streak. It is, as the reconstruction imagines, unstable, trembling, as if something unseen crossed before it.
Not normal.
Definitely not normal. And the specialized priests react instantly. They engage their scientific process. They time the event meticulously. The calibrator might call out the dimming. Irregular dimming duration, 7 heartbeats. They perhaps perceive a faint, maybe reddish shadow gliding across the star's projected face. This is not a predictable event like the Sophic Rising. This is an unexpected celestial visitor, something that requires immediate classification and recording.
So how do they try to understand what it is?
To understand the nature of this hidden one, Nebka reaches for maybe the most advanced piece of observational equipment they have in the chamber, a small prism, made perhaps of polished green feldspar, or maybe rock crystal. He carefully slides this prism into the path of the focused starlight.
What does that do?
It spreads the light out into its constituent colors. A delicate spectrum, like a tiny rainbow, appears on the wall.
They're doing spectral analysis thousands of years ago.
Primitive spectral analysis, yes. It demonstrates potentially extreme observational sophistication for the era. By splitting the light, they are looking for clues in the colors themselves, and they find one, a thin, dark scar. A complete absence of light, cutting right through the red region of the tiny spectrum.
A dark line in the spectrum. What does Nebka conclude?
His immediate recorded conclusion, according to this narrative reconstruction, it is a traveler, a hidden one. Something large has veiled the eye of Sa. This final story, whether strictly historical or illustrative, shows the full potential and vision for the pyramid system in these sources. It wasn't just limited to fixed annual timings, it was potentially capable of observing dynamic, transient, celestial events.
Like what? What could it have been?
Maybe a planet passing very close to the line of sight, or a moon, or perhaps even a large inner solar system asteroid in transit across the star's face, causing that brief dimming and maybe absorbing light in a specific way to create that dark spectral line.
And crucially,
they potentially had the scientific ingenuity not just to sight it, but to use the architecture and simple optics, like a prism, as a tool for basic physical analysis of the light itself. And then, importantly, to integrate that novel observation into the sacred record, maybe adding a new symbol to the star tables.
Okay, what a journey. We've traveled from this high-stakes ritual, watching for a crystal clear starlight, to a precise geometric analysis pointing directly at Thuban and Sirius. And finally, to the potential observation of a veiled, hidden traveler using a prism for analysis. The overwhelming conclusion drawn from the sources we've examined is that the Great Pyramid was potentially a multifunctional scientific tool, cleverly disguised as eternal architecture.
And our core findings, the most robust ones, remain those primary alignments. The pattern is just too strong to ignore. KC North targeting Thuban, the pole star of that era that's for eternity. KC South targeting Sirius, the Sothic calendar marker that's for life in the state. And QC South targeting the Orion family, linked to Osiris, that's for rebirth.
It fits the geometry and it fits the culture.
Perfectly. It fits the measured geometry remarkably well, and it aligns perfectly with the known Egyptian calendrical needs and funerary practices. It's a coherent system.
This really does change how we might perceive the Old Kingdom, doesn't it? It suggests they weren't just powerful kings demanding giant tombs built by sheer brute force and manpower.
It suggests a society with absolutely astounding metrology measurement skills and incredible ingenuity, capable of building these huge stationary instruments that could track the slow 26,000-year cycle of precession,
Mind-boggling.
and simultaneously time the annual flood of the Nile with absolute life-sustaining precision. It's a different picture of their capabilities.
Which leads us to our final provocative thought for you, the listener.
If these ancient astronomers, these priests, had the measurement skills and the sheer ingenuity to use architecture to track time and observe stars with such fidelity, what else might they have seen through those narrow stone shafts that remains undiscovered or maybe misinterpreted in the historical or astronomical record? And consider this twist. If the sky sometimes offers a chronological fit, like that potential 3250 BCE alignment for Alnitak in the KC South shaft that conflicts with the physical evidence we dig out of the ground, what does that really mean? Does the sky hold secrets about the true origins of the pyramid's design that might predate the pharaohs who actually commissioned the stone?
A chronology written in the stars versus one written in the sand.
Exactly. Something to think about, perhaps, next time you look up at the night sky.